Hi. So here we have to figure out the number of distinct integral values of n which satisfy this inequality. Now this inequality is basically an expression, basically division of two expressions which should be less than 0. Now when a number when divided by another number, if it has to be less than 0, there are two cases where the division can be less than 0. The two cases are when the numerator is positive and the denominator is negative. So positive number divided by negative number will always be a negative number, or the numerator is negative and the denominator is positive. These are the two cases where the division of two numbers will be negative. As in, one of the two numbers should be positive and the other should be negative, right? So let's take the first case. The first case here will be when we assume the numerator to be negative and the denominator to be positive. So 4 minus log of n base 2 should be less than 0 and 3 minus log of n base 4 should be greater than 0. So solving this, we get 4 is less than, taking this on the right hand side, 4 is less than log of n base 2, and again taking log of n base 4 here, 3 should be greater than log of n base 4. Now converting this inequality into exponential form, we'll have the number n. See, log of n base 2 should be greater than 4. This is possible when the number n is greater than base 2 to the power 4. So n should be greater than 2 to the power 4 from here. And here log of n base 4 is less than 3. So this means that the number n should be less than 4 to the power 3. N should be less than 4 to the power 3. 2 power 4 is 16 and 4 power 3 is 64. So n should be greater than 16 but n should be less than 64. So we have to figure out integral values of n. So the integral values of n that are possible are, it should be greater than 16. It can be 17, 18, 19 and so on, till a maximum of, it should be less than 64. So the maximum integral value can be 63. Okay. So n can take any integral value from 17, 18, 19 till 63. Okay. So the number of integral values will be 63 minus 17 plus 1. So 63 minus 17 will be 46, plus 1 is 47. So the total number of integral values that we'll get from the first case is 47 here. Okay. Now let's take the other case where the numerator will be positive whereas the denominator will be negative, right? So this is the second case. 4 minus log n base 2 should be greater than 0 and 3 minus log of n base 4 will be less than 0. Again solution will be same except the sign or the direction of inequality will change. So in second case, what we'll get at the end is n should be less than 16 and n should be greater than 64. Now we need to satisfy both these inequalities. Now think about it. Is it possible for n to be less than 16 and greater than 64 at the same time? Is it possible? Obviously it's not possible, right? So the answer from here, you will get no integral values of n. Since there are no integral values of n, the total number of integral values that we'll get will be from the first case itself, and the answer here will be 47. So the total number of integral values of n which will satisfy this inequality are 47. Thank you.